Now let's look at the sixth rule of the exponents. So this is the negative exponents rule, and the negative exponents rule is a wonderful and yet challenging kind of a rule, because in this rule you need to understand the effect of numbers in general as a numerator and a denominator, as well as you have to understand the effect of moving them up and down or swapping your numerators and denominators. An example here could be the following. Now, what it means is the following. It says that if a factor of a numerator, let's say now if a term in the numerator is what now, or a denominator is moved across the fraction bar. The fraction bar is that line which divides the numerator and the denominator. The sign of an exponent, of the exponent, is changed. Simple as that. So if you look at the following, let's start with basics here. So this is your numerator, this is your denominator. So what this rule says is that if you had an exponent here, right, and then this exponent now is changed or is moved across the fraction bar to come here at the denominator, then the sign of this exponent will change. Your sign changes in two ways, either positive or negative. Let's look at an example. An example is the following. So if you have 1 over x to the power m, positive m, you see, then your answer is gonna be what? Your answer is gonna be x to the power minus m over 1. So what happened here is the following. This term, which is a denominator, moved across to be the numerator, and the sign of that exponent in the denominator changed. So it changed from positive to negative, and the 1 does not change, it stays the same. This rule is very important when you're working with something of this nature. Let's say now on our second law, the quotient rule. So on your quotient rule now, it said you had x to the power 2 divided by x to the power 4, or let's be general and say x to the power 5. You had this answer. This answer will take you to the rule of negative exponents. You're gonna see now. So this answer is gonna be what now? The rule says divide the same times, subtract the exponents. So you're gonna have x 2 minus 5. You understand why we don't say 5 minus 2, because in order at which they appear is how you subtract. So your answer here becomes 2 minus 5 becomes x to the power minus 3. 2 minus 5 is minus 3. Your answer here can never stay negative mathematically. That's not allowed to stay with a negative exponent. So what do you do with that negative exponent? You apply the negative exponent rule. So now you are linking this rule with the second rule, or with any other calculation that you have done, and that leads you to the following now. This leads you to the fact that you have x to the power minus 3. It must be equal to, okay, generally any term that is just a whole number is divided by 1. It is divided by 1 like that. So just to clarify that, a 2 is also equal to 2 over 1. We know that a 10 is also equal to a 10 over 1. So a division of 1 is just the original number, hence we don't write the division of 1. But since we're going to be working with fractions here, I wanted to include that rule so that you understand. So let's swap the numerator and denominator. Why do we do that? Because we want to make our exponent positive. Don't leave your answer with a negative exponent, which means that when you swap these two now, swapping them means that they go over, they interchange their positions about the fraction bar. So interchange positions about the fraction bar. So if there is a fraction bar, this was a numerator, now it becomes a denominator. This was a denominator, so it becomes a numerator. What was the power here? The power was negative 3. Now it's going to be equal to positive 3. That's your final answer. That's how you apply the negative exponent rule.